minus 4 over e to the fourth. The least common denominator is e to the fourth, but I have to multiply this by e to the third. E to the third minus 4 is positive, because this is 8, more than 8. Minus 4 is positive, and this is always positive. So the answer f prime of -1 must be positive, not negative. And it made sense. These were correct. But with negative, from 0.35 does not go down to 0.47. It goes up to 0.47. So that's why I realized immediately my chart doesn't work. If it doesn't work, there is a glitch somewhere. Okay, enough of that. So let's look, thank you for your patience. So let's look at a word problem. Since we looked at a polynomial, or we looked at a exponential, I like to look at something like a different function, like a rational function. Okay, like for example this one. Minimizing cost of materials. The cost C in dollars right here to build a fence around a rectangular field with an area of 1,000 square meters is given by this. So the function is given to us, where x is the length of one side of the field. Find the value x for which the cost to build the fence is minimized. What is the cost of the value of x found in part A? All the same, everything the same. I'm on page 4. Let me copy the function. So this is 57 on 315. So this is c of x equals 8x plus 1200 over x. And they want us to find the minimum. Okay. Nothing different. You can say, but what is the interval? In this case, the interval is x is greater than 0, of course. Sometimes they give us intervals, sometimes they don't. Okay, so what do I have to find in order to find the minimum? That is the question, like we've done before, over and over. So how do I determine the minimum for such a function? What do I have to do first? What do I have to find first?
We have to find the f prime of it.
Of course, yes. F prime or C prime is the same thing, absolutely correct. C prime of x. Can anyone differentiate 8x for us?
8.
Very good. Now 1200 is 1200. Can anyone differentiate 1 of x for us? This is a major formula, super important, especially for chapter 4.
X to the power -1.
Yes, but we have a formula. Yes, you can do that like that. It's fine, but we have a formula that we discussed over and over.
-1 over x squared.
Thank you very much. So negative 1200 over x squared. Perfect. This needs a little bit of work. What is the least common denominator? That's why I wanted us to also work on a rational function. The least common denominator. There is only one denominator.
That's right.
Good. So then this one needs an x squared. So we have 8x squared minus 12,000. So now the next step, you're going to say you either set it equal to 0 for critical numbers or you set it equal to undefined. But it's undefined at 0, but so is the function. We know that x cannot be 0. So it's undefined, but where the function is undefined, so no critical numbers. Now, when we set it equal to 0, when is a fraction 0? A fraction is 0 only when
The denominator is equal to 0.
that is only when it's undefined. It has nothing to do with the denominator.
is when the numerator is equal to 0.
Exactly. Only when the numerator is equal to 0. A fraction, only 0 over 5 is 0. 5 over 0 is undefined. Good. So I'm going to try to divide both sides by 8. So x squared minus. So quickly I'm pretty sure, because it has 1,000, and 1,000 is divisible by 8. So 12,000 divided by 8. So we get 1,500. So 1,500 equals 0. So then x squared equals 1,500. How do we solve this equation? What do we need to do to solve x squared equals 1,500?
Will we take the square root?
Of course. And I should write plus or minus the square root of 1,500. No, because we're talking about cost for units. So it will only be 1,500, the square of 1,500. Okay, so this is not sufficient. Please remember, I have to create a table. I have to write C prime. I have to write C of x. I have to put 0. I don't know, we cannot say we created or produced infinite number of units, right? But the square root of 1,500, and I will approximate that, the square root of 1,500, the square root of the previous answer, 39. So approximately 39 units, 0. I have to study the sign of the derivative. So here's the derivative. I will plug in 0, not here because this is positive. I will not, this is always positive. I will only study the sign of this. When I plug in 0, what is the sign of the numerator? Because this is positive. What is the sign of the numerator when I plug in 0? Because I'm testing this side with 0.
Positive?
Yeah, careful. 0 minus 12,000.
Negative.
Good. And now on the other side of 39, I'm going to plug in 100. So this is 100. So it's 10,000 times 8, 80,000 minus 12,000. Exactly. Good. So at this point, it's very clear. It's very clear that this is indeed the minimum. But I have to determine it. So in the cost function, I have to plug in the square root of 1,500, or approximately 39. So right here, I'm still in shock, to be honest, that the calculator will not be able to compute this. My mind is still thinking about it. How come? Okay, so we have 8x, and then a plus 12,000 divided by x. And now I go to second and table. And what I need is, I'm going to put 39, although it's a little bit less. So I have 619.70. 619.70. So in order for the minimum cost to be achieved, we should manufacture and sell 39 units, and the minimum cost will be 619.70. This table has to be presented. We cannot say, oh, you asked me to find a minimum? Okay, I found it. It's when x is 39. It's not sufficient. We have to create a table and show that the sign of the derivative supports the minimum. Okay? So this is what we studied in this chapter, that the first derivative tells us where the function has a minimum or a maximum. So this is what we have to show as a support for our answer. So please remember that. Now the next section, which is 3.5, is all the same. So 3.5, more of the same. So let me go back to the first page. So graphing was one application of differentiation. The second one was finding absolute max min. The third one, again, finding absolute or relative or whatever we are asked max min. So I'm going to share my screen and jump directly to page 329. I don't have anything new here. Just different problems. And I let you choose. Again, sorry about the sound in the background. There are those notifications I showed you. Okay. When maximizing profit, minimizing cost, minimizing surface area, maximizing volume, all of the same. The same idea, we have to have a function and we have to find its max or min. That's it. I let you choose or I will.
Can we do a maximizing volume?
Yes. You want to do 19?
Sure.
From a thin piece of cardboard, 20 by 20. So we want to look at 19. And this is on page 329. So it's a 20 by 20. It should be, I should graph it more like a square. Square corners are cut out so that the sides can be folded up to make a box. Fine. Right? What dimensions will yield a box of maximum volume? What is the maximum volume? So we want max volume. Okay, so I'm going to reach in my recycling bin. And I am going to do this. Because this will be a square. Good. So I have a cardboard, and this is 20 inches, and this is 20, and this is 20, and this is 20. And now I'm going to remove squares of the same length and width from each corner, and 2 more. And now I'm going to fold up the sides. And here's the box. So I had 20 by 20, and this is X, and this is X, and this is X, and this is X, and X, and X, and X, and X. So now when I fold and I create the sides and I create this box, okay, I need to identify the width. I need to identify the length, or vice versa, it doesn't matter. And I need to identify the height. Why I need these 2 dimensions? Because I have to create a function that is volume. So I had 20 inches, but I removed these. I had 20 inches, but I removed these. So this will be the width. This will be the length. It turns out that they are going to be the same. So can anyone give us the width and the length? I will do the easy part. And I know that the height of the box is X. But how much is the width and how much is the length? They are the same. Can anyone give us the width and the length? The width is equal to the length, but how much? Anyone, please? Should I show the paper again?
So this would be the width and the length after we took the corners off?
Yes. Yes, because the volume depends on this and this and this and this, because now it has a height, and the height is x. But I need to know, so this was 20, but I had to remove these two pieces, so then how much is this?
10?
But you don't know x.
No.
We don't know x. So if this is 20 and I removed these, what is this?
20 minus x?
But how many x's?
20 minus 2x?
That's it. Absolutely. So this is 20 minus 2x, and this is 20 minus 2x. Good. So now we are ready to present the volume. What is the volume of a box? What is the formula for the volume of a rectangular box? Anyone remembers? So here is a rectangular box.
It's a length times
Yes, length times width times height. Length times width times height. I'm going to write it here for you. Length times width times height. But the length and the width are the same. So I have 20 minus 2x to the second power. And the height is x. I can put it in front or I can put it at the end. Perfect. Can anyone square this for us? And how many terms do we write? Can anyone square 20 minus 2x for us?
would it be 400
Yes,
plus
minus, it's minus here, I have to have minus. Minus 2 times the first times the second.
minus 4x
4 times 2
8
minus, sorry, minus 2 times the first times the second. So 2 times 2 is 4, 4 times 2 is 8. 80x plus
plus 4 x minus 4.
Can anyone square 2x squared 2x for us?
Is it 4x squared?
That's it. Good. So now we distribute x, and we found our function. This is the volume function. Okay, so that's page 6. So this is 4x to the third minus 80x squared plus 400x in the correct order. So this is the volume function. What next? What do I have to find next in order to find max min? What is my next?
Derivative?
Yes. So v prime of x. Can anyone differentiate v for us?
Well, x.
12x squared
Good.
minus 160x
Very good. Plus.
400.
plus
Thanks.
400.
Excellent. So of course v prime of x for critical numbers and v prime of x undefined, there is no such thing, it's polynomial. So quickly I have this feature. It's the apps, in the apps. So apps, I want 9. I want 12. I should have simplified a little bit. And 400, but that's okay. And 3.33, so x equals 3.33 inches and x equals 10 inches. Okay, so now let's think for a moment. I put my beautiful box in the bin again. So if this is 20, can x be 10?
No.
No, and I cannot make a box. If it's 20 and it's 10, this is not a box. If x is 10, this is no longer a box. So this is not possible. So I wouldn't even look at it. Now I have to see if this gives a maximum or a minimum. I do not know. So x, v prime of x, and v of x. So I found 3.33, and I know that v prime is 0. I need to study the sign of the derivative. Can anyone give us, when you plug in 0 here, what do you get?
400.
Very good. Now to the other side, let's say we plug in not 10, because 10 should be here, but I shouldn't even consider it, right? So I'm going to plug in 5. So I can put the function in the graphing calculator and just plug in 5 and see what I get. You don't have to do this by hand. Okay, so in y equals, I put in this function 12x squared. Sorry about that. So 12x squared. And minus 160x. I know the answer. It has to be negative, but we have to convince ourselves. We shouldn't trust anything anymore, not with this software. So when I plug in 5, I have to get a negative number. It must be. So it is, as expected. So we do have minus here. This is very clear. The typical situation for a maximum. No questions asked. So now what is the maximum? I don't know. I have to get the function, which is this. So I have to find v of 3.33. And of course, I will do it with a calculator again. So this time I go back to y equals and put in the function, because I need to plug in 3.33 to see what the maximum is, because that's what we are asked. Not just what should x be to give a maximum volume, but also what is the maximum volume. So 4x cubed. That's the function, that's the volume, minus 80x squared. And plus 400x. And now I plug in that 3.33. 3.33, and the function is in red. So it's 592.6. 592.6. And since we're talking about volume, the measurement unit is cubic inches. Cubic inches for the measurement unit for the volume.